Hello, ladies and gentlemen. Today we are learning how to represent and solve addition and subtraction of fractions. So we are going to be able to make models and pictures of them as well as solve addition and subtraction problems with fractions. So we know we can do it when we can use objects and pictures to represent the sum, so addition of two fractions. When we can use objects and pictures to represent the difference, so subtraction of two fractions, and when we can use objects and pictures to solve addition and subtraction of fractions. So showing addition of fractions, showing subtraction of fractions, and solving addition and subtraction. So we can talk to each other, we can use the sentence stems when the fractions blank and blank are combined. They will be blank together. So when we have the fractions 1/4 and 1/4 are combined, they will be 2/4 together, which is what we saw on Tuesday. So let's look. So we have Liam and Sam shared a chocolate bar. Liam ate 5/10 and Sam ate 3/10. Who ate more? And how much more? So here's Liam, here's Sam. If we see, we have 1, 2, 3, 4, 5/10 for Liam, and 1, 2, 3/10 for Sam. So, who ate more? Now, let's see if we can figure out how much more. So Liam did eat more. We can see that there is more here. And if I want to just compare, right? When I want how much more, this is a subtraction problem. If I was making a strip diagram from here, I would even say, hey, this is my question. I'm trying to figure out what is the difference between these two. So a way we can do that is, all right, taking away 1, taking away 1, taking away 1, which leaves me with 2/10. So the way that we would draw this is 5/10 minus 3/10 is equal to 2/10. And we can understand this, right? We have 5/10. When we take away 3 from 5, we have 2. And we did not change the size of these fractions. We didn't change how many pieces make a whole chocolate bar. It stays at 10 pieces make a whole chocolate bar. So our denominator stays the same. We're only taking away the numerator. Excellent. Now we have a pie. So even though it is now a circular fraction, we still have that 8 pieces make a whole. So let's see. Dad cut an apple pie into 8 pieces. Done. He served 4 slices to his children. Okay. So let's see if I can grab 4 of these. It's gonna be tricky. There we go. Okay. So 4 slices for his children and 2 slices for the mom. Okay. So let's see. We have children. We have mom. Now the question is, what fraction of the pie did Dad serve? Now, let's see. So we served 4/8, right? Because we have 1, 2, 3, 4 eighths for the children. How much did we serve Mom? That's right, 2/8. So, knowing what we have seen, what fraction of the pie did Dad serve? So we have 4 pieces and 2 pieces, which means we have 6 pieces, and we do have 8 slices make a whole, so it's still 6/8. Now, the other way to think about this is, how much did we start off with? How many pieces do we start out with? We started out with 8/8. We start off with a whole pie. And if we still have 2/8 left over, right? We still have this much. That means 8 take away 2, 6/8 were served. Okay. Now for our final work. Okay. So a garden has 4 yellow flowers, 4 red flowers, 2 green flowers, 6 blue flowers. So the question is, what fraction of the flowers are yellow or red? Well, first off, how many flowers make up our entire garden? So counting, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So, of all the flowers, right, of all 16 flowers, I have 4 flowers are yellow, 4 flowers are red. Which means, how many would be either yellow or red? Eight 16ths. Absolutely, 8 out of 16. Now, using that same idea, how can we show which fractions are green or blue? Well, out of 16, there are 2 green flowers. Out of 16, there are 6 blue flowers, which means we have 8 out of 16, 8/16 green or blue. Now finally, what fraction are red, green, or blue? So looking at before, we had 4/16 are red, 2/16 are green, and 6/16 are blue, which gives us the answer 12/16.